Hello guys, we're continuing on with our BARKER past paper, and it was extension 1 semester 1 of 2012, and question 12 reads, write down the equation or equations of the asymptotes of y equals 4x over x minus 3, and this puppy's a 2-marker. So there's two concepts we're going to use in this, and I'll explain them individually and then how they relate to the question as we go. The first one is this concept of vertical asymptotes, which you might have come across before. And I've just written the function out here again, so y equals 4x over x minus 3. And you can see when x equals 3 here, we're going to have 3 minus 3 on the bottom. So it's going to be 4 times 3, so it's going to be 12 on the top and 0 on the bottom. And this is undefined, dividing by 0. And when we're dividing by 0, that's like one of the big gotchas, or the telltale signs for a vertical asymptote, because there's no point that's defined at x equals 3. So when the denominator equals 0, usually there's a vertical asymptote. I've just written it as the heading, vertical asymptote. So I've done a cheeky heading, and sorry, don't worry about all this, but at 3, just only focus on this little orange diagram now. I've done a vertical asymptote at x equals 3. So this has the equation of x equals 3. Beautiful. So now obviously you can see I've done a few things here, and I've already worked out that there's a horizontal asymptote at y equals 4. So I'll explain how I got that one. Now, horizontal asymptotes and asymptotes that just aren't vertical in general can be found out this way using long division, and hopefully you've seen it before. But it's a technique that it took me a while to learn and pick up. It's like riding a bike. So once you've done it, you'll always remember. And if I'm going to explain this particular example with these particular numbers in general, but if you're having difficulty with the process, look up Khan Academy. Just hit Khan Academy, or just go onto YouTube and hit Khan Academy and write in Polynomial Division, and this guy is an absolute legend. You might have heard of him before. A guy called Salman Khan. He's actually the guy that inspired me to do these videos, and he's got a really good lesson on what polynomial division is and this division that we're going to use in this problem. So the main steps are, so say we want to know another expression that's going to give us insights into it for what this expression is, for this expression. So what we do is we put the denominator in this position, do our little division symbol that we did like in 1 or 2, or I don't know, I just remember doing it when I was really little, and you put your 4x or the numerator in here. And we asked ourselves, with this highest order term, what do we have to multiply this number by to get this expression? And hopefully you can see that the answer here will be 4, obviously, because... And then what we do is we times this back out. So our first step is we ask, what do we do to this number, to this x here, just to get this expression? And the answer is we times it by 4. And then what we do is put a 4 here and we expand it back out. So that will become 4x minus 12. Beautiful. Now, hopefully, there's actually a plus 0 here. If this was 4x plus 3 or something, we'd put the 3 there. But we're just going to put 0 there for now. And our next step is what we do. We've got these two polynomials and we subtract them. And these are always going to cancel out because, I mean, that's why we put this 4 here, so it would cancel out. So when we put a 4 here and we expand it back out, we get 4x. And the reason why we put a 4 here is because we asked ourselves, what do we have to times x by to get 4x? And obviously that's where this 4 came from. So these zeros will cancel out. And then it's 0 minus 12. And we're going to get, of course, get plus 12 because minus and a minus is a plus. And the important thing to remember with this long division, when this 12 becomes of a lesser order of magnitude. So what I mean by that is obviously x squared is higher than x, which is higher than a constant like 4. So this is the highest, and we're getting smaller there. So when this constant or this thing here is less than the highest term in here, so here we've got a linear function, just x, and here we've just got a constant, then this will become the remainder. So what we can deduce from that is, this is very important, this step is really crucial. So 4x over x minus 3, we've worked out, can be also written as, we write this 4, So it goes into it 4 times. And then we've got a remainder of 12 over x minus 3. So we've got to remember the number that we get up the top here, so that will be this one, is how many times it goes into it. And then this little thing that pops out here, sometimes it will be 0. I mean, if it goes into it a perfect amount of times. But if it doesn't, like in this case, this will be the remainder. So it's very important you remember that this will be the remainder. Beautiful. And just to really, make you satisfied with the fact that this red and blue expression are equivalent, what I'm going to do is to the right-hand side, I'm going to rewrite it. So I'll write the right-hand side equals... Now, I'm going to make a common denominator on the right-hand side. So 4 times x minus 3 all over x minus 3. So you can tell these x minus 3 will cancel. We'll just be left with 4. So this thing here is just the same as this 4. Plus 12 over x minus 3. Beautiful. And then, obviously, I'm going to expand this out. So we're going to get 12x minus 12 plus 12 over x minus 3. Beautiful. And, hang on, where have I got this 12x from? Sorry. This 4 times x here is just 4x. Don't know where that 12 came from. Sorry if that confused you. And then we're just going to end up with this minus 12 and plus 12 will cancel, and we'll just end up with 4x over x minus 3. So obviously this right-hand side is the same as this left-hand side, which I've just shown you there. But like I said earlier, if you have any qualms with long division or you still haven't quite got it, go onto youtube.com and type in Khan Academy Polynomial Division, and this guy from MIT, who's got like 6,000 degrees, will give you a good lesson on that. Beautiful. So now what I've done is, so we've worked out that this function can also be written as 4 plus 12 over x minus 3. Beautiful. So we've got two equations for it here. This little one in green, which was the original one, and this pink one. And what this function, the reason why we've done this whole thing to do long division is because this tells us something interesting that this might not. So when we put in x equals infinity here, we're going to get 12 over infinity minus 3. So 12 over infinity, which is 0 because, a really big number on the bottom, this will shrink to 0. And we'll end up with 4 plus 0. So when x equals infinity, y will equal 4, because this will be 0, and you'll just have this 4. And is that necessarily, that's not necessarily obvious to me anyway, when you put x equals infinity into here, that you're getting 4 back out again. So that's a good thing. So at x equals infinity, we're going to put in y equals 4. So that means that as x gets really big, we've got this vertical asymptote at y equals 4. And as x gets bigger and bigger and bigger, y is going to get closer and closer to 4. So there's another vertical asymptote that's a horizontal asymptote that we've got here at y equals 4. So I'll just write that down. And this question only asked for the asymptotes. So we've found 2 asymptotes there, and that's actually all there is. But just to check that we're on the right kind of scope, I'll just draw it for you anyway. So I've just plotted a few points here. And there's no harm in doing that. I still do it at uni. So when x equals 0, y equals 0. So we just chucked x equals 0 and got y equals 0 out. So and I've just put that point there. And I've done that. I'm sure you're very comfortable with the art of plotting points and putting x values in, and all these red dots are things that we've got. And so what you can see is we're going to end up, which is consistent with these points that are coming out are consistent with the asymptotes that we've found. So this graph is going to look something like this. So you can tell that I'd write explicitly. So I'd say the asymptotes, funny word, asymptotes, are at x equals 3, y equals 4. Beautiful. So hopefully that was clear to you. Yep, it's a very, very interesting question. Don't feel, if you've been uncomfortable with this long division, just look up this Khan Academy link. I hope it was clear, and I'll see you guys in the next question.